When Elon Musk first revealed Terrafab to the public, most attention went toward the facility's incredible size and massive capacity. It is expected to cover around 100 million square feet and provide 1 terawatt of AI computing capacity each year, equivalent to roughly 100 to 200 billion custom AI chips and memory units annually. But there is one feature in Tesla and SpaceX's Terrafab layout that many people may have missed. It's a massive circular structure positioned directly in the center. Elon Musk said on X that Terrafab would eventually become 50 times larger than the Pentagon. He also posted 6 letters, FFTW, hinting at what could be taking place inside that enormous circle. Over the next 10 minutes, we are going to uncover the surprising story behind Terrafab's central circle and how Elon Musk could potentially trigger one of the biggest transformations in the semiconductor industry in decades. As everyone knows, Tesla is no longer concentrating entirely on income from electric vehicles. Instead, the company is placing enormous bets on Optimus robots and robot access. At the same time, SpaceX is expanding Starlink and pushing artificial intelligence into space. But all of these projects have one major dependency: AI chips. Right now, Tesla cannot simply purchase unlimited quantities of chips whenever it wants. Production from companies such as Nvidia, TSMC, and Samsung remains constrained. Elon Musk has even suggested that current global AI chip production could satisfy only around 2% of the possible demand created by the broader Tesla and SpaceX ecosystem. This is no longer simply a normal shortage of chips. It is a shortage of semiconductor manufacturing capacity on a global scale. And that is precisely why Terrafab is being developed. Elon Musk is reportedly aiming for a facility covering approximately 100 million square feet, which would be around 10 times the size of Gigafactory Texas, or roughly 15.4 pentagons. From what has been revealed so far, Terrafab is being designed as an integrated manufacturing ecosystem where chip logic, high-speed memory, advanced packaging, and many other production processes could potentially take place within the same massive complex. But its enormous size is only the most obvious part of the story. Very few people are focusing on how Terrafab could actually manufacture its chips. Elon Musk previously described an incredibly rapid feedback cycle: create a photolithography mask, produce the chip, test it, make changes to the design, create another mask, and repeat the process. Rather than moving designs between separate companies and different fabrication facilities, the entire process could potentially take place inside Terrafab. And if you think that is already ambitious, look again at the enormous circle located at the heart of Terrafab. One ex-user studied the blueprint and asked Elon Musk whether a particle accelerator could be located beneath the circle. Musk replied with 6 letters, FELFTWI. In other words, free electron laser for the win. So what could that actually mean? Let's break it down as simply as possible, because many people assume semiconductor manufacturing is straightforward. That might have been closer to reality with older generations of chips, but today's advanced AI processors are dramatically more difficult to manufacture. One of the biggest challenges in modern semiconductor production is EUV, or extreme ultraviolet lithography. Think about it this way: as engineers make transistors smaller, they need extremely short wavelength light to create microscopic patterns on silicon wafers. Modern EUV systems operate with light having a wavelength of approximately 13.5 nanometers. The difficulty is producing that light efficiently. Today's EUV machines use powerful lasers to strike tiny droplets of tin. The tin turns into extremely hot plasma, which then produces EUV light. The method works, but it requires tremendous amounts of energy and creates debris that could potentially damage the incredibly expensive mirrors inside the equipment. That is where a free electron laser inside Terrafab could become a potential game changer. Instead of relying on tin, a free electron laser accelerates free electrons to speeds approaching the speed of light. Those electrons then travel through a specialized series of magnets known as an undulator. As the electrons are forced to oscillate, they emit light. With precise control, those light waves can interact coherently and create a powerful, clean, tunable beam. In theory, this could produce the type of EUV light required by the semiconductor industry. More importantly, if such a system could operate at industrial scale, its impact could be enormous. Why? In a conventional semiconductor fab, every EUV lithography machine needs its own dedicated light source. As production increases, that can become a major bottleneck. Terrafab is reportedly targeting production of hundreds of thousands of wafers every month, making the problem even more important simply because of the scale involved. Based on what has been discovered, a centralized free electron laser capable of delivering EUV light to multiple lithography machines could fundamentally change the architecture of the fab. Instead of treating the light source as a bottleneck inside every individual machine, it could become shared infrastructure serving the entire facility. That could remove the need for every system to depend on its own dedicated light generation process. There would also be no constant stream of tin droplets creating debris. In theory, the approach could provide greater power, improved energy efficiency, and substantially better scalability. That is exactly why the huge circle at the center of Terrafab could be so significant. But Terrafab may have another important advantage that could help make the entire concept practical, and that advantage is Intel. Constructing an advanced semiconductor fabrication plant is nothing like building an automobile factory. A 2-nanometer fab or anything beyond it requires ultra-clean environments, EUV equipment worth hundreds of millions of dollars, extremely pure chemicals, and precision at the atomic level. Even a tiny defect can destroy an entire wafer batch. Tesla has extensive experience with large-scale manufacturing. SpaceX has experience with rapid development, optimization, and iteration. But Intel has decades of experience operating advanced semiconductor fabrication facilities. That is why Intel's participation in Terrafab could be much more important than simply having its name associated with the project. Terrafab also reportedly recruited Gary Zhang, a former Intel manufacturing executive with 17 years of experience, as its first director. He previously managed Intel's 18A manufacturing operations. With a projected investment of $119 billion at full scale, Elon Musk is not merely spending money on another chip factory. The Tesla CEO appears to be trying to build an entire ecosystem combining capital, massive scale, artificial intelligence, manufacturing capabilities, and semiconductor expertise. So where will a factory of this magnitude obtain enough electricity? Running a 100 million square foot facility intended to support 1 terawatt of AI computing capacity annually would demand an extraordinary amount of power. But SpaceX has reportedly introduced another major element into the Terrafab plan. According to recent information from Grimes County, SpaceX, which is leading the project, plans to develop its own power infrastructure for Terrafab rather than depending entirely on the Texas public grid. Specifically, SpaceX says it intends to construct natural gas-fired power plants alongside very large battery storage systems. That means Terrafab is being planned not merely as a gigantic semiconductor factory, but potentially as a self-powered industrial ecosystem, giving SpaceX greater control over the continuous and enormous energy requirements of chip manufacturing. Interestingly, the current plan does not mention solar panels or Tesla's solar energy systems, even though Tesla is one of the major companies involved in Terrafab. That creates an interesting contrast. Tesla is well known for its electric vehicles, Powerwall, and especially Megapack, its grid-scale energy storage technology. Many people might have expected Terrafab to become a massive showcase for renewable energy, but the current direction appears to be different. The primary energy source is expected to be natural gas combined with large-scale battery storage. And the reason is actually quite practical. An advanced semiconductor fab cannot operate only when the sun is shining. It needs what the industry calls firm power, meaning a stable and continuous electricity supply that can operate with virtually no interruption. Think about a facility containing billions of dollars in equipment running around the clock. A major power outage could interrupt manufacturing, damage wafers and machinery, and potentially disrupt the entire production process. Solar energy, meanwhile, is naturally intermittent. It can produce enormous amounts of electricity during daylight hours, but not at night, and weather conditions can change output as well. When Terrafab is targeting electricity consumption on such a massive scale, depending only on solar power and batteries could require an enormous and extremely costly storage system from the beginning. That is why natural gas provides SpaceX with something extremely valuable: control. By constructing its own power plants, SpaceX would not need to wait years for a connection to the public electricity grid. It could have much greater control over the project's schedule. It could also reduce additional pressure on the local grid and lower the possibility of Terrafab competing for electricity, with the growing number of AI data centers being built throughout the United States. And here is another crucial point: energy is becoming a bottleneck almost as important as chips. AI requires GPUs. GPUs require semiconductor fabs. Semiconductor fabs and AI data centers require enormous quantities of electricity. So the AI competition is no longer simply about who can obtain the most chips. It is increasingly becoming a race to secure chips, factories, and energy faster than everyone else. According to the initial plans, once Terrafab begins manufacturing, it could start at approximately 100,000 wafers per month, with a long-term target of reaching 1 million wafers every month. If Terrafab reaches that level, it would no longer be simply a fabrication facility designed to support Tesla. It could become one of the world's largest semiconductor manufacturing centers. Terrafab is reportedly expected to generate at least 3,000 jobs in the surrounding Texas region, while its first phase alone could require around $16.8 billion in capital investment. And if every planned future phase is completed, the total investment could eventually reach approximately $119 billion. That would make Terrafab the most expensive project Elon Musk has ever undertaken, exceeding the cost of his previous major projects. Tesla needs millions, and potentially billions, of AI brains for Optimus. Cybercab requires enormous computing power to operate autonomously. SpaceX needs chips for Starlink and AI systems operating in space. XAI requires continually increasing computing resources to train more powerful AI models. All of these projects share the same fundamental weakness. Without enough chips, everything becomes constrained. Instead of continuing to depend completely on external semiconductor supply chains, Musk appears to be attempting to create the manufacturing capacity required by his own companies. That is why Terrafab could be much more significant than its 100 million square foot footprint suggests. Tesla does not necessarily need Terrafab simply to sell chips. It needs those chips to build an entirely new ecosystem of intelligent machines and AI systems. AI-5 is planned to power full self-driving, robot access, and Optimus, followed by AI-6, AI-7, and future generations. Meanwhile, the D3 family is being developed for Starlink and AI applications in space, where chips must survive radiation, extreme temperatures, and the vacuum of space. These are the types of chips that could reshape Tesla and SpaceX. So, if that $119 billion investment really creates semiconductor manufacturing capacity on an unprecedented scale, the bigger question becomes: just how dramatically could Terrafab disrupt the semiconductor industry? That's the end of this episode. If you enjoy watching Tesla turn ambitious ideas into real-world plans, leave a like and subscribe. We'll continue uncovering the engineering and technology shaping the future.